Alright, so it's day 10, and hopefully day 10 goes well. Maybe we'll go back to the little Intcode computer we built, I think on day 8. Was that day 8? It was day 8. They're going to wait a couple days and then call back to it, and I won't remember which day it was. And then it will spend a bunch of time hunting it down. But that's alright. We're not trying to get on the leaderboard here. We're trying to come up with good, clean solutions. I think there's more people playing this year, or maybe I'm slower, but in years past I was able to get on the leaderboard a couple days. This year doesn't seem like it's happening, and I'm okay with that. So, let's see what today's problem is. Patching the airport data support, you discover weather forecast of a massive tropical storm. Before you can figure out whether it will impact aviation plans, however, your device suddenly turns off. Its battery is dead. You will need to plug it in. So one problem, the charging outlet near your seat produces the wrong number of jolts. Always prepared to make a list of all the voltage adapters in your bag. If your voltage adapter is rated for a specific output voltage, first input, any given adapter contains input 1, 2, or 3 jolts lower than its rating and still produce rated output voltage. In addition, your device has a built-in voltage adapter rated for 3 jolts higher than the highest rated adapter in your bag. So if your adapter list was 3, 9, and 6, your device's built-in adapter would be rated for 12 jolts. Treat the charging outlet nearest you as having an effective voltage rating of 0. Since you have some time to kill, you might as well test all your adapters. Wouldn't want to get to your resort and realize you can't even charge your device. Use every adapter in your bag at once. What is the distribution of voltage differences between the charging outlet, the adapters, and your device? For example, supposing you're okay, I didn't quite follow that. So suppose you have the following voltage ratings. With these adapters, your devices would be rated for 22 jolts. Because adapters can only connect to a source 1 to 3 jolts lower than its rating, in order to use every adapter, you need to choose them like this. Charging outlet has 0, so the only adapters connected directly would have to have 1 of those. The only one you have is 1. From your 1 jolt, the only choice is your 4. From the 4, 5, 6, 7 are valid, and we're not skipping adapters. You have to pick the adapter rated 5. Similarly, the next choice is we need 6, and then the 7. The adapter is one rated 10. From 10, choose 11 or 12, choose 11, and then 12. After 12, the only adapter is rated 3, then 16. Finally, your device's built-in adapter is always 3 higher, so its rating is 22 jolts. This example, when using every adapter, there are 7 differences of 1 jolt and 5 differences of 3 jolts. Here's a larger example. Find a chain that uses all your adapters to connect the charging outlet device built-in adapter. Count the voltage differences. What is the number of 1 jolt differences multiplied by the number of 3 jolt differences? Okay, so it sounds like I just sort them and then add a 3 jolt distance at the end. So let's see if and what do I want to call these adapters? Adapters 1 equals, I guess I'll do raw. Raw 1 is this. Raw 2 is, and then there was another, so if I understood it correctly, and let's say adapters 1 equals int x for x in raw 1 dot split on new lines, and adapters 2 equals int x for x in raw 2 dot split on new lines. Okay, so let's do that. And now let's do from collections import counter. We'll just use that for counts. And def skips adapters is a list of ints, and so we'll say from typing import list. Okay, and no, I can't. It's too big. And skips is going to return us a let's say a dict of string and int, so it's going to return us the counts of the skips, and so we'll say adapters equals sorted adapter, so we'll sort it, and then we wanted to add one at the end that was 3, so adapters dot append max adapters plus 3, if I understood that correctly, and then I want to return counter of next adapter minus previous adapter for prev A next A in zip of adapters and adapters 1. Okay. And what's it complaining about? It's complaining because I'm returning a dict and not, oh, come on. Seriously? All right, that's fine. How about that? And let's say, what are we going to call this? One jolt differences multiplied by the number of 3 jolt differences. Actually, you know what? I'll just do this, and I'll say skips 1 equals skips adapters 1. Assert that skips 1 times skips 1 3 equals, and this is where we're going to find out if I understood the problem. 7 differences of 1, so that would be equals 7 times 5. Skips 2 equals skips of adapters 2, and assert that skips 2 1 times skips 2 3 equals, and now there's say 22 times 10. Okay, so let's run this and see if I got it right. Invalid literal, and is this the thing where I always forget to? Yes, that is the problem. There was a blank line, and the one day I didn't do a strip. Okay, so see, skips 1 is 3, 5, and okay, so let us let's see what I did not understand. So let's go back and look at this. Starting out with sector 0, so these only when you have an adapter related 1 jolt. Difference of 1. Oh, because I should have put a 0. Is that the issue? Is that I got 5 times 6 and it should have been 5 times 7. Is that right? Yeah, that is right. Okay, so so let us do that, and now let me try it and see if it works, because that's why we do unit tests. Okay, good. So now let's get our puzzle input, and okay, and let's say adapters equals int x for x and f. Skips I'll call this count skip since it does a counter. That's skips equals count skips adapters print skips 1 times skips 3, and then actually assert that set of, actually let me add this assert up here, because let me do this. Diffs equals next A minus prev A for, here's what I want to do. I just want to be safe, and say return counter for diffs. And I want to assert that all the diffs had to be this for diff and diffs. So I just want to safeguard this because they said all the differences will be between 1 and 3. So let us, closing parentheses does not match opening parentheses. That is true. Okay, and this is 2432 and all my asserts passed, so let us try it. That's the right answer. Okay. To complete a determinant of adapters, you need to figure out how many different ways they can be arranged. Each arrangement needs to connect the charging outlet to your device. Previous rules about when adapters can successfully connect still apply. The first example above, the one, supports the following arrangements. Charging outlet in your device's built-in adapter are shown in parentheses. Given the adapters from the first example, the total number of arrangements that connect the charging outlet to your device is 8. The second example above, the one that starts with 28, 33, 18, has many arrangements. Here are a few. Okay, in total, this can, so there must be more than a trillion valid ways. Surely, what is the total number of distinct ways you can arrange the adapters to connect the charging outlet to your device? Okay, so that is, did it say they're all distinct? I think they must be all distinct. So this sounds like a dynamic programming problem. Okay? And why is it a dynamic programming problem? It is a dynamic programming problem because the number of ways I can get to 22 is the number of ways I can get to 21 plus the number of ways I can get to 20 plus the number of ways I can get to that. Okay? And so so what do I want to do? So let's say so now I don't want to count the skips. Instead, I want to count the paths. And adapters, which is a list of ints, and that's going to return an int. Okay? And so again, I'm going to do the same things, and basically, except now, what I want to do is I want to say that I don't need them to be sorted anymore. So instead, what I want to do is I want to say adapters dot append 0, adapters dot append max adapters plus 3, and then let's say Pylance is not going to like this because I can't assign a set to a list. But still, this is how many things are in here? Oh, 107. Okay, I don't need to do that then. Okay, and let's say output equals adapters minus 1, and num ways equals 0 times output plus 1. Okay, so so basically, num ways I is the number of ways to get to I. Okay. And what do I want to do? So num ways 0 equals 1 because we know we always start there. Num ways 1 equals and let's say 1 if 1 in adapters else 0, and num weighs okay, and num weighs 2 equals num weighs 0 if 2 in adapters else 0 plus, so I'll talk a little bit about how I'm doing this in a second. Num weighs 1 if 1 in adapters else 0. Okay, and now for n in range 3 and output plus 1, if 0 in adapters, I should be doing this more efficiently, num weighs n plus, not 0, that doesn't make any sense. If 1 is an adapter, so that means we can get there from n minus 1, plus equals num weighs n minus 1, which means every way to get to n minus 1 is also a way to get to n. If 2 is in adapters, this is why I was thinking about using a seb, because there's only 100 things in there. I actually don't care that much. Num weighs n plus equals num weighs n minus 2, right? So if I have an adapter, actually no, sorry, I've got that wrong. If let me think about this differently. I think I've been doing this wrong. So the number of ways to get to 0 is 1. The number of ways to get to 2 is, sorry, it's actually 2 if 1 in adapters, and so okay, so I can always get to 0. If 1 in adapters, then num weighs 1 equals 1. Otherwise, it still equals 0. I can't get to 1 if 1's not in adapters. If 2 in adapters, if 1 in adapter, if 2 in adapters and 1 in adapters, so if they're both there, then that means that there's 2 ways I can get to 2, right? I can go to 1 and then 2, or I can go L if 2 in adapters, but 1 is not, obviously, then I can get to 2 in one way, and then otherwise I can get to 2 in 0 ways if 2 is not in adapters. Okay, good. So that's more correct. Okay, so for n in range 3, output plus 1, if n not in adapters, continue. So if n is not in adapters, then I can't get there. Otherwise, num weighs n equals num weighs n minus 3 plus num weighs n minus 2 plus num weighs n minus 1. So this is like a Fibonacci kind of thing. And finally, I want to return num weighs output. Okay, so I think that will probably work. And so now assert that num weighs of adapters 1 equals 8. Okay, and assert that I called it num weighs. Is that not what I called the function? Count paths. All right. Count paths, num weighs, count paths. Count paths adapters 2 is 19208. Okay, So let us see if that's right. Okay, well, it passed my unit test, so it seems pretty good. Um, so now let's go back and uh, print num ways of adapters. Okay, it's not called num ways, it's called count paths. Print count paths of adapters. Now let's run it, and that is a large number. So let's try it. So right answer, one gold star closer to saving your vacation. You got ranked 704 on the stars leaderboard. We've completed day 10. All right, good. So it might seem like I took a big mental leap there. So in fact, in both things, it might seem like I took a big mental leap. So let's think about this. So when I looked at this first problem, it says, if you use every adapter in your bag at once, what is the distribution of voltage differences between the charging outlet, the adapters, and the device? And each charging outlet has to go 1, 2, or 3 higher to the next one. So the only way to use every one of them at once is to use them all in order. So what I said is I'm just going to sort them and get them all in order. And then as we saw, I had to put a 0 at the front and max plus 3 at the end. So I put all those there. And then I have all the adapters in order, plus 0, plus 3. And then what I'm going to do is I want to look at the differences between the previous adapter and the next adapter. So one way of looking at those is by zipping adapters with adapters from 1 on. Zip will stop whenever either of its sequences ends, or any of its sequences ends. And so this gives me basically the first element of this is adapters 0, adapters 1. The next is adapters 1, adapters 2. So it gives me my elements sort of in a sliding pairwise window. Then if I take their difference, that gives me the diffs. To be safe, I asserted that all the diffs were between 1 and 3, so they're supposed to be. And I just returned a counter. So counter will just count all the diffs. And then what they wanted me to return was so I get this counter. Counter is like a dict that you can actually look up things that aren't in it. It'll give you 0. So I said, I want to know number of 1s times number of 3s, and assert that that's right. And so that worked. The second part was actually more interesting. And that's saying, instead of just the longest path, we want to consider every possible path. So, here's a path that includes everything. But here's a path that says, you know what? Let's see. Because we can go 1, 2, or 3, we actually could have skipped this 11, right? And so just gone straight from 10 to 12. Or we could have skipped this 6 and just gone, and so on. So basically, any path from 0 to this max that never takes a step of more than 3. And so we have to count all the ways to do that. And obviously, if you start like enumerating all possible combinations, that's a lot of things. And so you can use dynamic programming. Dynamic programming is basically saying, take a problem where you have a smaller subproblem that can help you solve the larger subproblem, and solve it that way. And it can be very efficient. So here, the smaller subproblem is, so like in this one, the problem I'm going to solve is how many ways to get to 22. The smaller subproblem is, how many ways to get to n. So, if I knew how many ways to get to each of these, then I could say how many ways to get to 22. And so what I did was basically the following. I said, I have these adapters that I add 0 and I add the max plus 3 to. And I say the output that I want is that last value. That's fine. And so I construct like an empty array or an empty list that I'm going to dynamically program my number of ways into, right? And so I start with a base case. It's similar to recursion. You could use recursion and memoization to do the same thing, basically. Like, you could do this with recursion starting at the top. You just have to use memoization. Like, it's like Fibonacci, right? So if I said number of ways to get to 22 is number of ways to get to 19, 20, 21, and then number of ways to get to 19. And so, like, if I did it naively, I would be calling like number of ways to get to 6 like millions of times. And so I don't want to do that. So I got to store my results. And so, like, another way to do that is just by making this array and filling it in a little bit, right? So just so I didn't have to deal with off by one errors, I made it one bigger than I could so that actually, no, I needed to make it that way. So that's fine. It's not off one errors. And so what I said is there's exactly one way to get to position 0, and that's where I start at. And so I know that I get there. And if 1 is one of my adapters, then I have a way to get to 1. I go from 0 to 1. If 1 is not in my adapters, then I can't get to 1, and so it stays 0, which is what I set it to. And now, if both 1 and 2 are in adapters, then there's two ways to get to 2. I can go 0, 1, 2, or I can go just 0 to 2. Otherwise, if 2 is in adapters and 1 is not in adapters, I have one way to get to 2. I can go 0 to 2. Can't go through 1 because 1's not there. And then if 2 is not in adapters, I can't get to 2. Okay? And so now that I have, 0, 1, and 2 populated, I can iterate over the rest. And I'll say, let's go for each n in 3 up to the output that I want. If n is not one of my adapters, then obviously there's no way I can get to it, right? Because I can only get to the ones that are my adapters. If n is my adapter, then I'm allowed to get to it from either of the 3 preceding steps. So like if n is 10, I can get there from either 7 or 8 or 9. So I say, how many ways can I get to 7, which I've already computed because I'm doing this in order. I can get there all those ways. How many ways can I get to 8? Okay, I've already computed that, so I can get there all those ways. And how many ways can I get to 9? I can get there all those ways. And because to get to 10, I have to either come from 7, 8, or 9. If I add those together, that tells me all the possible ways I can get to 10. And basically, even in this input, that where the biggest one is like, 160 or something, that means that this is just a for loop that, this 4 is 160 times. This was, if I change to a set, this would be an instant check. But basically, I'm doing like 100 something, and this is 100. So I'm doing like 200 operations each time. So that's like nothing, and it runs super fast. And if you try to do it recursively without, memoization or something, it would take forever, and it would actually never stop. It'd be like the heat death of the universe or something. So anyway, that was that. It went pretty well. I got to lecture you about dynamic programming, which is always a joy. I hope you like hearing me talk about dynamic programming. And sup. All right. So that's it. I'm going to stop streaming and go to bed. All right. Good night.